the whole quarter. The final will be on the 15th during our normal class hours. So if we meet 3 to 5, I'm just going to put that on there. 3 o'clock to 4:50. It's an hour and 50 minutes. So we'll meet Wednesday, the 15th, from 3 to 4:50 for our final online, just like we meet for our classes.
Professor, you still want us here a little early, like you sent out an email already, right?
I think that would be best. That way I can make sure everybody's logged on. And then when I send everything out about 3 o'clock, then you'll have the full 2 hours. Otherwise, you might lose some time. So yeah, it'd be a good idea to get logged on a little bit early. Any other questions?
Thank you, Professor.
Sure. Other questions? Okay, looks like there are no other questions. If you do, just feel free to break in and ask. So 8.1, we're talking about matrix solutions to linear systems, and we're going to talk exactly what that means. We're going to take a look at what is a matrix, and the plural is matrices. And we're going to look at setting up equations in a matrix and then using the matrix to solve those equations using a couple of different methods. So that's the idea of what we're going to cover. And a matrix really is just a rectangular array. And the information in the matrix is arranged in rows and columns. So if I said, here's a rectangular array, then this might be row 1, and maybe this is row 2. And up here, I might have column 1 and column 2. And I might have 1, 2, 3, 4, whatever the values are inside this array. And these are called the elements. Of the matrix. We're just getting down some terms here. So we'll put an array into a set of brackets. We'll have elements within the brackets. We'll call these rows and we'll call these columns. Okay, and then the first step in solving a system of linear equations using matrices is to write the matrix in augmented matrix form. And if we write it in augmented matrix form, then the coefficients of each variable I place, let me just go ahead and set something up. Like if this were, I might set up something like my augmented array, and the columns might be labeled, X, Y, and Z, my variables. And then the rows here would contain whatever the coefficients of those variables are. So let me set up I'm going to set another thing here. I'm going to put there is no equal sign here, but these are the constants. So we take a set of equations, put the labels, the variables that we're going to use above the columns, and then the coefficients in these areas here, in these elements here, and then we'll have the constants. So for an example, if I had a set of equations, 1, 2, 3 equations, and maybe I say 2x plus y plus 2z z equals 18. Maybe that's one equation. And maybe x minus y plus 2z equals 9, and maybe a third equation, x plus 2y minus z equals 6. And we could start trying to solve this like we normally do, take equation 1 and 2 and eliminate a variable, and take equation 2 and 3 and eliminate a variable, and then we have a 2 by 2 and so forth. So that is a method that can be used. Substitution is a method that can be used. But the power of the matrix operations is that we can take matrices that are more than even 3. We could take 4 or 5 or a large number, really, which would be very error prone and more steps to solve. And so this method of solving using a matrix, loading the equations into a matrix and then setting up an augmented matrix and then moving the rows around, doing row operations, is a very powerful method. So let's just take a look. Say we're given these 3 equations, and I load them into an augmented matrix. So I'm going to say, here's my matrix here, and I'm going to draw a line here, and I'm going to say the constants go on the right side of the line. So I'm going to say 18 and 9 and 6, and I'll just put some light lines there just so that I can put my values in. So I have 2 for the x values. I'll just put x as a reference above here in the columns, and a 1 here for the y coefficient, and 2 for the z coefficient. So I have x, y, and z. So here are the variables here. And we have the constants here. And we have the coefficients here. Those are these values here. So I have 2, 1, and 2. I have 1, minus 1, and 2, and 1, 2, and minus 1. So that would be loading up our augmented matrix to see if we can solve this system of equations using some matrix operations. And so just to take you through some of the matrix operations, I might have something that says, let's see, let's take row 1 and swap it with row 2. So I might do something like this. I might say row 1 swap or interchange with row 2. That's the operation that I'm going to do. So if I do that operation, what I end up with is 1, negative 1, 2, and 9. So what was in row 2 goes to row 1. That's what this operation means. And then what's in row 1 goes to row 2.
Professor, can you
Yeah.
move the paper up, please?
Yeah.
Thank you.
Let me just raise this camera just a little bit here so we can see more. Okay. Okay, and then so our second row then would be what the first row contained, which is 2 and 1 and 2 and 18. It contained this row here. Just to swap those 2 rows, and we don't do anything to the third row. We didn't do any operation on the third row, so that remains the same. 1, 2, negative 1, and 6. So the key point here is we do this operation, and that's called a row operation. And we generate a new matrix. We haven't changed anything. It's just like swapping these equations around, but now we're just using them in abbreviated form, where we're just taking the coefficients and putting them down here. Still have our three variables, X, Y, and Z, and our constants. Okay, questions on what we did there at all? I'm just going to keep moving through various row operations. Go right ahead.
Could you explain why like you swapped it again? I'm so confused on like what is the
Why or how?
I guess why.
Why? We'll get into that. The idea is what we're trying to do is develop a matrix where we have ones down the diagonal,
Oh, okay.
and we want to have zeros below those values. And then if we take a look, if we were able to manipulate this matrix such that we had a row of ones here and zeros down here, if these were all zeros, then I could say, well, look at Z, we have 1Z is 6. So whatever manipulations I had to do to get this set up like this says I have, and here it's a negative. So if it were a negative, I would have to put a negative, but we're going to end up with ones here. So I'd have Z equals 6. That's this value here. So we've done some row operations. We've moved these equations around. We're just using the coefficients of the equations. And now we've been able to solve for one of the variables. Then I can plug that back in and say, well, if this is 0 and this is, I know this value Z, then I can solve for Y. So I could say Y plus 2Z equals 18, plug 6 in for Z and say Y plus 2 times 6 equals 18 and so forth. Y equals 18 minus 12 equals 6, whatever it turns out to be. Okay, so we're using these row operations. We're manipulating these coefficients in order to solve for the variables that we have. In this case, we have 3, but there are other problems where we'll have more than 3. And you can see that it might be a little more difficult to solve a problem with 4 or more variables if we have to start using 2 equations at a time and start reducing from 4 to 3 to 2 and so forth. Other questions on that? Okay, so let's take that augmented matrix that I had. It had X, Y, Z, and I was at 1, -1, 2, and 9, 2, 1, 2, and 18. I'm just rewriting 1, 2, -1, and 6. And now let's say I want to take, maybe the row operation I do is negative, let's say negative row 1 plus row 2 and replace row 2 with that. So I'm taking negative row 1 and adding it to row 2 and then replacing row 2. So I'll just draw what I'm going to end up with down here. Now I haven't done anything to row 3. So that's still going to be 1, 2, -1, and 6. And I'll just put some light lines in here just so I can see what I'm working with. So if I do this operation, negative row 1, and let's actually, let me even do a little bit more. Let me do -2 row 1. So if I do -2 row 1, -2 times this value, and then add it to row 2. So row 1 remains the same, -1, -1, 2, and 9. But what I'm going to do is do this to row 1, add it to row 2, and replace row 2. So -2 times 1 is -2. Okay, now if I add -2 and 2, what am I going to get? 0, right? And that's what I'm aiming to do, is get zeros below the diagonal set of ones. So this is the operation I did on row 2 to allow me to get a 0 in under the X variable. So I did -2 row 1 plus row 2. So -2 times here is going to be -2 times -1 is 2 plus 1. That's going to give me a 3 right here. And then -2 times 2 is -4 plus 2 is a -2. And then -2 times 9 is -18. And -18 plus 18 is going to be 0. So by doing this operation, let me just highlight that. So doing this operation on row 2, I didn't change row 1 and I didn't change row 3. I only changed row 2. And now I have 1, 0, 1. And then under Y's, I have -1, 3, and 2. And under Z, I have 2, -2, and 1. Okay, questions on what we did there? And why we did it? The object is we want to go down this diagonal and we want that to be all ones. The goal is to get 1, 1, 1 and 0, 0, 0. That's what we're looking for. So that we can then solve for X, Y, and Z, whatever these constants are. So here's your Z value that we can substitute back in as discussed earlier. Okay, questions? Okay, let's do another operation, and let's do, got this in the way here, but let me do negative row 1 plus row 3 and replace row 3. So row 1 is still 1, -1, 2, and 9. Row 2 didn't change. It's 0, 3, -2, and 0. But what we changed is row 3. And you can imagine what we're trying to do. We want to adjust row 3 so we can get a 0 down here. So if we did a negative row 1 and add it to row 3, that's -1 plus 1. That's a 0, isn't it? That's what we wanted. And then -1 here, that's +1 plus 2. That gives me a 3. Negative here is -2 and -1. That's a -3. And a -9 and 6 is a -3. So after doing this row operation, I'm marching right along. I've got the 1, I've got a 0, and I've got a 0. So I'm making progress. I just have to keep working my way through. The next thing I'm going to try and do is see what I can do to get a 1 here. What operations do I have to do to get a 1 here? And I could say, well, there's a couple of things I could do. Let's see, what would be an interesting one to do here? If I, let's see, I guess I could simply, let's see, if I want to get a 1 here, I guess I could just divide through by 3, couldn't I? I could just take a row 2. I haven't labeled these out here, but these are always row 1, row 2, row 3, and these are X, Y, and Z. I haven't put them up there, but those remain the same all the way through. Now let's say I want to take row 2 over 3 and replace row 2 with that. So just divide row 2 by 3. So if I do that, that's going to remain a 0. And rather than rewrite this, I'm just going to erase it. So if I divide this by 3, this becomes a 1. Okay. And then if I divide this by 3, I get a 2/3. So let's see, 1/3. Well, let me see. Maybe it'd be better to do another operation before I do that. That might make it easier. 0, 1, -2, 0, 3, -2, 1. Maybe what I ought to do is I could take negative row 1, add it to row 3. So you can see there are multiple ways. There isn't just one way to go through and try and solve these. There's multiple ways, And as you practice and go through them, you're going to find that, well, it might work easier if I did it one way or another way. So let's say if I had 0, 3, -2, 0, and I ended up here at 0, 2, -1, and 6. Let's just try something else instead. Let's say, given that I'm starting here, and I wanted to get this thing, I want to get this, see, 0, 3, -2, and this actually was 1, wasn't it? 1, 2, that's a 1 there, isn't it? Bring this one down, so that goes to there. So now I want to figure out an operation that I can use to get a 0 here. I could say, well, if I took negative row 1 plus row 3, I end up getting rid of that, don't I? Okay, that's what I did here. So if I take negative row 1 and add it to row 3, then row 3 is this 0 here. Everybody follow that? So that'd be a 0. And then negative row 1 and add it to row 3. Well, let's see. Negative this is positive 1. Add to that. So then this becomes a 3. Okay, we'll just step through this. And then negative row 1, add this, we get a -3. And a negative here. And what did we get over here when we did that operation? Can we do this operation? What do we put here?
Be a -3, Professor.
-3.
-9 plus 6.
Right. So we're going to get a -3 here. Okay. Everybody follow me on what we're doing here? Now, if I take, let's see what would be interesting to do here. If I swap row 2 and row 3, if I say row 2 and swap it with row 3, let's see what I get. So if I swap, I'll go ahead and rewrite that. Row 1, row 2, row 3. And I'm going to swap. So I'm going to put 0, 3, -3, -3, 0, 3, -2, and 0. So when I do this operation of that says swap, replace row 2 and swap it with row 3. So we end up with 1, 0, 0, -1, 3, 3, 2, -3, and so forth. Okay, questions? Now at this point, I could say, well, what if I divide row 2 by 3? So take row 2 and put it over 3. So what's going to happen? That's the remains a 0. 3 over 3, that becomes a 1, doesn't it? Becomes a 1. -3 over 3 becomes a -1. And -3 over 3 also becomes a -1. I'm just erasing these to make it a little easier for you to see without having to rewrite everything. And then what did we do to row 3? Any changes to row 3? New volunteer? Or I can call on somebody, either way works. What do we do to row 3? That's the question. Anyone? Christopher, what do you think?
It's a yes or no question, and the answer is no. You were only working with row 2.
All right, thank you. Okay, so now pay attention, everybody, because I'll keep asking questions to make sure you're following me. Now, what's the goal here? We've got zeros here and ones here and here. And our goal is to get another 0 here and another 1 here, because once we've done that, our X, Y, and Z, we can now solve for Z. Okay. So what if I take negative row 2 and add it to row 3. Well, let's see. Let's try negative 3 row 2 since we have a 1 here and we want to get this to a 0. If we take row 2 times a negative 3 and add it to row 3, so this becomes negative 3, and that's a positive 3, so that force that to 0, won't it? And then we'll replace row 3 with that. So that's what we're going to do, this operation right here. So I'm going to rewrite this, and I'll have 1, negative 1, 2, and 9, 0, 1, negative 1, and negative 1. And I'm going to create a new row 3. Negative 3 times row 2. That's going to be 0, isn't it? Plus this, so that's still a 0. That's what we want. Negative 3 times row 2, that's a negative 3 here. And add it to that 3, that gives me a 0 here, doesn't it? Negative 3 here, that gives me a what? Positive 3, negative 2, that gives me a negative 1 here. And negative 3 times this plus this, looks like that gives me a 3. Looks like that should give me a 3, shouldn't it? And then over here, I get a 0. Let's see, 1, negative 1, 2. That looks good. 0, 1, negative 1. That looks good. 0, 0. Well, this was a 1, wasn't it? We had a 3 and a negative 2. That was a 1. And then 9, 1. And what do we do here? Negative 3 times that plus row 3. So that was a 3, isn't it? So now look what we have. By doing these 1, 2, 3, 4 operations, 1, 2, 3, 4 operations, we've been able now to solve X, Y, Z. We're now able to solve for Z. No X. So if we were to write this out, we could say this says X minus Y plus 2Z equals 9. That's what this first set of values would give us. Second set would give me no X's, 1Y, negative Z equals negative 1. And the third equation would be no X, no Y, and Z equals 3. Okay, so doing these 1, 2, 3, 4 operations, we can now solve for Z. So we have one of the values. And if I have one of the values, I can do a back substitution into the equation above and say Y minus Z, which is 3, equals 9, or Y equals 9 plus 3. Is that right? 9. Z equal, look like that was a Y minus 3. Sorry. Y minus, so that's going to be 3 minus 1. That's going to be a 2. So we're going to get not this, but a Y equals 2. 3 minus 1 is 2. And for X, we can substitute, and maybe I'll just leave it set up the way it is, minus Y, which is 2, plus 2Z, which is 3, equals 9. So X equals 9 minus 6 plus 2. Bring this over to be negative 6. Bring this over positive 2. So 11 minus that is 5. So our solution set becomes X is 5, Y is 2, and Z is 3. So we put a box around it, put an arrow to it, say, by doing these 4 operations on these 3 equations, these row operations on the matrix, we able to solve it. Now you could, I guess the proof in the pudding, you could, as you go through some of these problems we're going to do, you might think about, how would I solve this if I were going to use substitution or elimination? And then you might, as we go through some other problems, decide, is this easier or is substitution or elimination easier? But on a test, make sure you always answer the question that's asked. If it asks you to solve the problem with substitution, you want to do that. If it's addition, elimination, you want to do that. And if it says solve it using matrix and row operations, then you're going to want to do that. Okay, I'm going to stop right there and ask for any other questions before I take you through some other examples. Okay, looks like everybody is doing all right. So let's just do some basics then. I'm going to give you a system of equations. X minus 2y equals 2. And 2x plus 3y plus z equals 11. And y minus 4z equals negative 7. So here's equation 1, 2, and 3. And if the problem is put this in augmented form, augmented matrix form, could you do it? Do we know enough to put that in augmented matrix form? Go ahead and do that, and then we'll continue. And I don't think it'll take you too long to do that, but let's just see. And I can call on somebody to take us through that. And what did augmented matrix form look like? We had to draw our brackets, put our divider between the constants and the variables. And the 3 variables are x, y, and z. And what were the leading coefficients here? What is it for the first equation?
1
1, very good.
minus 2, negative 2,
Negative 2 and
0,
0 for z and 2
2.
here. Very good. Very good. All right. How about row 2, new volunteer?
2,
2,
3,
good.
and 1,
Okay,
and equal 11.
good. And the last one, let's see, we don't have any x's, so it looks like that's a 0.
1,
1 for y,
negative 4,
negative 4,
negative 7.
negative 7. Very good. Okay, so we've got our 3 rows, our variables, our constants. So if the question were simply write the system of equations in augmented form, that's all you would need to do. Here's our solution right here. You don't necessarily have to solve every set of equations that's given you. You just have to answer the question that's asked. Okay, so you might have a question that says, put it in augmented form. All right. You might have a situation where you are given the augmented matrix. You might be given 4, 12, negative 20, and 8. And 1 and 6 and negative 3 and negative 3, negative 2, and 1. And you might have a question that says, perform the indicated row operation. And it might say, perform row 1 interchange row 2. So really then we're just going to swap these, aren't we? So we'd end up with 1, 6, minus 3, 8, 4, 12, negative 20. And that's not going to be 8, is it? That's going to be 1, 6, negative 3, 7. This value here. And then we bring down the other one, 4, 12, negative 28. So this becomes row 1, row 2, and row 3 we didn't do anything with. Negative 3, negative 2, 1, negative 9. So we were given an augmented matrix of this form, and we were asked to do a row operation, which just says swap row 1 and row 2, and we'll get 1, 6, negative 3, 7 in row 1 after the operation. And row 2 will then contain 4, 12, negative 28, and row 3 didn't change, did it? Okay, does that make sense to everybody? What's going on there? Questions on that at all? Okay. So if it said take row 1 and divide by 4, well, if you're going to do it after you've already done this swapping, so then we take row 1 and divide by 4, so we get 1/4, 6 over 4, negative 3 over 4, 7 over 4 for row 1, and 4, 12, negative 28, negative 3, negative 2, 1, and negative 9. So row 1, row 2, row 3 would look like that after the second operation. So if it says do this operation and then do this operation, you'd end up with something that looks like that. Okay, does that make sense to everybody? You just do them in whatever order they're given. If it says take 3 times row 2 and add it to row 3, that really says replace row 3. So if I took 3 row 2, it'd give me a 12, and add it to this, 12 minus 3 is going to give me a 9, isn't it? So row 3 would end up with 9, and 3 times 36, that'd be 34. That'd be negative 60, and negative 59, and then 24 minus 9 is going to give me what? 24, 9, what is that? 15, 14, 13, what is it going to be? 10 from that is 14, 9 from that would be 15, wouldn't it? Okay, so in doing this operation as it's shown here, then we just multiply row 2 times row 3 and add it to row 3, which says that's going to replace row 3. I guess that's one thing you want to make sure you're aware of. If you're adding to a row, that row is going to be changed to whatever you're adding to it. So row 3 now becomes this value here. Okay, questions?
So basically on the test, are you gonna give us like those commands? For example, like row 1 divided by 4?
You could be given those commands, yes.
Okay, so we don't have to think of those ourselves, right? That's
Well,
not what the test is on.
if you're given that, you wouldn't have to think of it yourself. If it says, given this, perform this operation, then you would simply do that operation.
Okay.
And the objective of a question like that would be, does the student know how to do this row operation?
Okay.
You might come back and say, then do this row operation, then do this row operation, just to say, do you know how to manipulate the rows using these row operations?
So do we ever have to like make up those those commands ourselves?
Well, I think you would if you're given the following. For instance, the problem says use, and I'm going to call this problem 3. I'm going to say use the matrix operations to solve the system. The system of what? The system of equations. And what's the system of equations? Well, 1, 2, 3. 2x, 2x plus y plus 2z equals 18. X minus y plus 2z equals 9. X plus 2y minus z equals 6. Now, if the question said, I'm going to give you this system of equations, and it could say solve any way you want. And you could, well, what are the ways that I could solve a system of equations? And we said, well, I could graph it. Probably not too good a method. This looks like it's in 3-dimensional, so it's going to be pretty tough to come up with the x, y, z coordinates of where they cross. That's probably not a good method. B, I could substitute. Well, let's see, I could solve this one for y and substitute in and keep reducing. That might work, and you could do that. But it says use matrix operations, so we can't use that. So C then, we have add, eliminate. We can't use that because it says use matrix. So D, the matrix operations are what we needed. But we know there are 4 different ways. If it just said solve any way you want, then you say, well, I know I've got 4 different ways: graphing, substitution, addition, elimination, and matrix. Which way should I use? And then it would be up to you. And you might get a question like that that says solve the system of equations. You might not necessarily say solve the matrix. It might say solve the system of equations using matrix operations. Okay, so maybe we should give that a try then and see if we are successful. So let's see what that might look like. Get my other piece of paper around here. So if I start out with 2x, y, 18, 9, 6. So maybe the first thing I want to do is put this in an augmented matrix form. So this becomes 2, 1, 2, 18, 1, minus 1, 2, 9, 1, 2, negative 1. This is a positive 2, isn't it? And 6. So now we have it in augmented matrix form. Now you'll notice that it didn't say, oh, use this operation. It just said solve using matrix operations. So now we've got this, and we've got to decide what to do. X, Y, Z, row 1, row 2, row 3. And we know that one of the first things we want to do is to get that's our first thing, is we want to get a 1 here, don't we? So we've got to decide what we want to do to get a 1 there. And there are several ways to do that. And so there isn't just one method to use to solve these. You're going to have different ways that different students are going to use. But one easy way might to simply say, hey, I'm going to take row 1 and swap it with row 2. I'm going to get this 1 up here. I'm not going to multiply this by a half, for instance, to get that to be a 1. You could. That is an approach. Or you could just move one of these up there. So if I say swap row 1 and row 2, and I'll highlight the movements I'm going to make here. If I do that, I end up with 1, negative 1, 2, and 9. That becomes my new row 1. And row 2 becomes the old row 1, which is 2 plus 1 plus 2 and 18. And row 3 didn't change. 1, 2, negative 1, 6. Okay, so this is the result of doing this operation on this augmented matrix, and I generate a new augmented matrix. And the goal was to get a 1 up here, and I was successful. There it is. And now we could say, well, what do I want to do for my second operation? And I might say, well, you know what I want to do is I want to get a 0 right here. So is there some row operation I can do to get a 0 there? And one method might be to say, well, you know, I can take -2 times row 1 and add it to row 2. And let's see what happens when we do that. And that generates a new one. So -2 times row 1. Now, have I changed row 1? No, I'm operating on row 1 and adding it to row 2. So this will generate a new row 2. Row 1 remains the same as 1, -1, +2, 9. But row 2 now, if we multiply row 2 times row 1 by -2, I get a -2 here. Add it to row 2, -2 and +2 is 0, which is what I wanted to get there, wasn't it? That was the objective. So by doing this row operation on row 2, I get 0. And then -2 up here gives me a +2, plus 1 gives me a 3. -2 here is -4, plus 2 gives me a -2. And -2 here is -18. And a +18, that gives me a 0. So as a result of this row operation replacing row 2 becomes this. Row 3 didn't change, did it? 1, 2, -1, 6. Okay. So with 2 operations, then I have a 1 and a 0, and then I can continue. Now let's say I want to get a 0 here. That's my next move. So what could I do to get a 0 there? And there'd be different approaches, but I could say negative row 1 plus row 3, for instance. So row 1 and 2 don't change. 1, -1, +2, 9. Row 2 is the same, 0, 3, -2, 0. Remember, these are X, Y, Z, row 1, row 2, row 3. And what I'm changing is row 3. Negative row 1 added to row 3 and replace row 3. So negative row 1 is -1 plus 1. That's a 0, which of course is what I wanted, isn't it? I want to replace this thing with a, so I've got 1, 0, 0 by doing this operation here. Let me just put that there like that. Okay, and then negative row 1, that's +1, and plus row 3, that's going to give me a 3. And a negative row 1 is -2, -1, that's -3, and -9 plus 6, that's a -3, isn't it? So after doing these operations, I have 1, 0, 0. All right, making sense? And remember the goal, I'm going to get a 1 here. I want this to become a 1, and I want this to become a 0. So I'll have 1, 1, 0, 0, 0. Then I'm going to want to make this a 1 as well. So I'll have 1, 1, 1 down the diagonal, which is here, and 0 is below it. Then I can say the Z is this, and I can solve for Y and solve for X. Okay, everybody doing okay? All right, let's say we take a row 2 and divide it by 3. So row 2 over 3. See what I'm going to get here. 1, -1, 2, 9. Row 2 over 3, that's going to give me 0. 3 over 3 is a 1. Negative 2 over 3 is a negative 2 over 3. 0 over 3 is a 0. And we didn't do anything to this last row. Plus 3 minus 3 minus 3. Let's see how that's looking for us. So we have 1, 0, 0, negative 1, 1, 3, 2, negative 2/3 and 3, 9, 0, and 3, x, y, z. And row 1, row 2, row 3. So we have 1, 0, 0. And we have a 1 here. So we want to get a 0 here, don't we? In our next operation. Let's see, do I have anything in the back? Yes, I do. Let me get a new sheet here. And before I do a new operation, questions on anything we've done so far? We're just going to continue using these operations. Okay. So let's see here. I got 1, negative 1, 2, 2/3. Let's see, negative 3, row 2, negative 3. Yeah, if I wanted to get this to 0, I guess I could say negative 3, row 2, and add that to row 3. So negative 3 times this will make this a negative 3. Add it to that. So I think what I'm going to do is just leave this alone. So negative 3, row 2, that's going to be 0. And that 0 is going to remain, isn't it? Negative 3, row 2 would give me a negative 3 here. Add it to row 3. Then this becomes a 0, which is what I wanted. And negative 3 times this gives me negative 3, gives me negative 3. So these 3's will cancel. And if I add that to row 3, let's see, what am I going to get here? Negative 3, row 2 plus row 3. Looks like I get 0, 1, negative 2, 0, 0. This is going to be a 1 because I'm going to cancel that out. So I'll get a 1 here. And over here, I got the negative 3. So after doing that row operation, let me get this up so you can see it here a little bit and highlight what I did here. So the next matrix that I have then is 1, 0, 0, negative 1, 1, 0, 2, this, and this is actually negative, isn't it? And then 9, 0. So looks like I'm in good shape. I've got 1, 0, 0, and I've got 1 here. I've got 0 here. That's good. What I don't have is a positive 1 here. I don't want a positive 1. I mean, I don't want a negative 1. I want a positive 1. So let's take row 3 times negative 1, which is the same, I guess it's saying negative row 3. So I'll just say negative row 3. So that's still 0, still 0. This becomes a positive 1. That becomes a positive 3. So as a result of that operation, I now have exactly what I need. I have the diagonal 1, 1, 1. Below the diagonals, zeros. That's good. So now I can solve. And I can say, well, 1z equals 3. So how many operations did I do here? 1, 2, 3, 4, 5. I did 6 operations. And I ended up with z equals 3. And then I can substitute back in. I can substitute y minus 2/3 z, which is 3, equals 0, or y equals 2 by substituting back in, and then substituting in for x. I get x minus y, which is 2, plus z, which is 3, equals 9. So x equals, and this be a positive 1 over here. It's a negative 1. So let's see, it's, where am I? X equals, have these right, 9. That's 6. And do I have this right here? 1x minus y, which is, oh, that's, I guess that's a plus. That's a negative y, isn't it? So that means that's a plus. So we get 3, 5. My arithmetic is screwed up here. Let's see, we have y is 2. That's good. X, excuse me, z is 3. That's good. So x equals -2. That should be a -2 plus 6. That's what it is. -2 and then 2 z's. 2z. So it's x equals 9 minus 6 plus 2. That's 11 minus 6, which is 5. So x equals 5. So doing the 1, 2, 3, 4, 5, 6 operations, y is 2. So our solution set I'll put here is x is 5, y is 2, and z is 3. There's our solution set here. So let me put this up here again and make sure we're all clear and understand and agree with what's going on here. Okay, we were given 3 equations. We were asked to solve using matrix operations. We know that there are 4 ways we can use, but we were asked to use matrix. So we swapped row 1 and 2, took a -2 times row 1, added to row 2. Okay, so now we've got 1 and 0, negative row 1 plus row 3. So now row 3 is 0 in the x location. And then divide row 2 by 3. Take -3 times row 2 and add it to row 3. We're down to here. And then divide row 3, or -1 times row 3, and we get 0, 0, 1, and 3 because we want this to be positive. Okay, then just solve for z, substitute back in, solve for y, substitute back in and solve for x. So we get x is 5, y is 2, z is 3. Okay, questions? Okay, looks like everybody's doing fine. So let's then take one that might take a little more imagination. And I'm going to give you the problem, then we'll take a break and you can work on the problem. So if I say use matrices to solve, and I say we have 4 equations. We have w minus 3x minus 2y plus z equals -3. I have 2w, 7x, y, 2z equals 1, 3w, 7x, 3y, 3z, -5, and 5w plus x plus 4y minus 2z equals 18. Solve using matrices. So let's see, what time do we have here? 3. Looks like it's just about break time. So let's take our break. You can think about this if you want during the break. And then we'll come back and see if we can solve that. Okay, any questions before we take our break? Okay, good. See you at 4:05. Okay, are we all back? Let's go ahead and do the row operations for this 1, 2, 3, 4. I guess we could say 1, 2, 3, 4, 5 by 4 matrix. So we have, maybe that's one thing we should talk about too. We could call this 4 rows, 5 columns. So we're going to call this a 4 by 5 matrix. 4 rows, 5 columns, 1, 2, 3, 4, 5. And I'm going to give you the row operations. And if you did a negative row 1 plus row 2 and replace row 2, what would we get? So what I've done is I've created the augmented matrix right here. So I put in just the coefficients 1, -3, -2, 1, and -3 from above to create this matrix. And then I want to do these row operations to create a new augmented matrix. And again, the goal is to get a diagonal of 1s and 0s below it. So if I do this first operation, negative row 1, and add it to row 2 and replace row 2 with that, what do I get? Negative row 1 is giving me a -1. So I'm not changing anything in row 1. So I'm just going to put 1, -3, -2, +1, -3. If I take negative row 1 and add it to row 2, what do I get? So there's a -1 times row 1. Okay, so negative row 1 plus row 2, -1 plus row 2. Am I going to get anything here? Well, not if I do a 1, am I? Because that's a 1, that's a 2. So how about I make this 2? -2 row 1 plus row 2. Now what happens? -2 times 1 is -2 plus row 2. That's a +1. So that goes to 0, doesn't it? -2 row 1 plus row 2. So -2 here is a -6. Okay, -2 row 1, -6. And add it to, so that gives me a +6, doesn't it? -2 row 1, so that's +6 minus 7. That's a 1, isn't it? -1. And how about the third one here? -2 times -2 is +4 minus 1. It's +3. And the last term, -2, here is a -2 plus 2. Like that's a 0, huh? And -2 here plus over here, it's a -6. Let's see, -2, that's a +6 plus 1, +7. So it looks like row 2, here's row 1, row 2, row 3, row 4. And so that took care of that operation. Now we want to operate and generate a new row 3. -3 row 1, so it gives us a -3, and add it to row 3, which was a +3. So that gives us a 0. That's what we're looking for, isn't it? We want 1s and 0s underneath those 1s, don't we? So -3 times row 1 and -3 here. And we add it to that, so that'd be 9 minus 7, that's a 2, and that's positive. And -2 times -2 is 4 minus 1, that's a 3. Row 3. And what do we get? A 0 here. And to speed up the calculations here, what'd you get for the constant out here? Remember, we're doing that. We're doing this operation here. -3 row 1. So it gives me a -3. Plus row 3. -3 here gives me a 9. And over here, what do I get? -3 row 1 plus row 3. So we're generating a new row 3. 0, 2, 3, 0. And what do we get out here? What's this value right here?
4.
4. Very good. Very good. And then we want to do this last. So we did that one. Then we want to do this last operation. -5 row 1 and add it to row 4. So we're going to create a new row 4. So -5 times row 1. So that gives me a -5 and add it to row 4. That gives me a 0, doesn't it? Which is what I wanted. -5 times row 1, that's positive 15 plus 1, that's positive 16. -5, that's positive 10. And 4, that's 14. -5, -2, -7. And -5 up here, that's positive 15, positive 18, 18 and 15, that's 33, isn't it? Okay, so we did this set of operations and we ended up with this new matrix here as a result of this. So now we're at here. And we have 1 in the upper left, followed by zeros below it. Okay, questions on what we did there? Now we want this to be a positive one, don't we? So if we take this negative row 2, we operate on row 2 with a negative, we'll get 0. This -1 will become a positive 1. This positive 3 will result in a -3. 0 will remain the same, and the positive 7 will be a -7 as a result of that. Okay. Questions? Now I can continue going down through here using these operations. If I gave you -2 row 2 plus row 3 and -16 row 2 plus row 4, you're going to generate a new set, a new augmented matrix, and we can end up then solving for W, X, Y, and Z. Okay, so the idea is want you to be comfortable and familiar with moving through using matrix operations to get an echelon. This is called a row echelon here of ones, positive ones with zeros below it using the row operations. Now, have I explained enough on how to do this, or do you want me to keep going through this? It's kind of up to you. I'm willing to do whatever you guys think is most important for you. Kind of comfortable with how we're going through here and manipulating these variables so that we can get ones and zeros where we want them? Let me show you one other thing. What were we given here? We were given 1. Let's say I'm given the following. Let me find something interesting here. Let's say I'm given 2x plus y plus 2z equals 18. And x minus y plus 2z equals 9, and 1 plus 2y minus z equals 6. We've had these, haven't we? We've seen this before. Now we've gone through and we've maybe done some solutions on that. So this is what we're given. And if we were asked to use matrix operations, we could do it. Right? We know how to use matrix operations. But what we haven't covered is, could we use our calculator? Use a TI-84 to solve. Now, we want to be able to use matrix operations, and you'll be asked that on the use of matrix operations in this class and other classes. But you also want to be able to use your calculator to solve this. So what I want to do is take you through that. So let me get out my calculator here. Before I do, I'll ask for any questions before I move on to the calculator part of it. Questions at all? Okay, so if I grab my calculator and if I go down here to matrix operations, if I do a second and a matrix, it's above the x to the -1 here. If I press that matrix right here, I'll get this screen. And now what I want to be able to do is define a matrix on my calculator. So in order to define a matrix, I'm going to arrow over here, take the cursor and go over to edit. Here's my cursor, and I go over to edit and I hit enter. And I say, what do I want my matrix size to be? And if I want it to be 3 by 4, I can enter a 3 and enter a 4. And after each value I enter, I press enter. And that says, okay, you've generated a 3 by 4 matrix, and I'm calling it matrix A. And then you want to set up some values that you're going to put in your matrix. Now, in this case, and I'll put this over here. Remember when we set up our augmented matrix, 18, 9, 6, 2, 1, 1, 1, -1, 2, +2, +2, -1. Okay, let's make sure we've got our matrix set up properly. 2, 1, 1, 1, -1, 2, 2, 2, -1. Yeah, okay, so here's our augmented matrix. And I want to enter this into my calculator. So it is a 1, 2, 3 rows and 1, 2, 3, 4 columns. Okay, so the columns are across the top and the rows are vertical. So now I enter the values that I want. So I'm going to just enter those values here. I'm going to replace what's in this matrix that I uploaded here. So if I hit 2 and hit enter, and 1, enter, 2, enter, 18, enter. So after I do that, I have 2, 1, 2, and 18, which is what I had here. And now I'm going to enter 1, -2, -1, 2, and 9. 1, -1, 1, -1, 2, and 9. 1, -1, 2, and 9. Okay, good. And then I want 1, 2, -1, and 6. 1, 2, -1, and 6. So I have loaded the matrix into my calculator. Okay, so I've set up the size. I've told the calculator the size I want. Calculator is calling it matrix A. I've loaded up with the values I want. So I'm going to now get out of this operation. So I'm going to do a second and quit to get out of that operation. And then I'm going to say, okay, I want to use the calculator to see if I can solve this. So I'm going to again do a second and matrix like I did earlier. And the calculator says, now what do you want to do? And I'm going to say, well, I'm not going to do editing anymore. I'm going to do a math operation, which is shown here. And the question is, which math operation do I want to do? And I want to do a reduced row echelon format. That's what we saw when we had this. Remember, we had this set up with ones here when we solved it earlier. See, where do I have it? This right here. When we had this is called a row echelon matrix. That is to say, we have ones along this echelon right here. This is called an echelon. And we have ones along there. And we're going to use the calculator to look for that. So the calculator says, which math function do you want? And I go up here and I say, I want the reduced row echelon format, RREF. That's the one we want to use. So then I'll press enter, telling the calculator that that's the function I want to use. And then it says, well, what matrix do you want to use? So I'm going to not go there. I'm going to say, well, I want, at this point, I'm going to go down and get a matrix. And it says, you have a matrix A, which is a 3x4 matrix, which is the one we've just loaded. So I'm going to say, yes, that's the one I want. So now the calculator is going to use the reduced row echelon format to solve matrix A, the one we've just calculated. So I'm going to hit enter. And the calculator very quickly comes up with, here's that row echelon right through here, and zeros below it. And so now we have X, Y, Z across the top and row 1, 2, and 3. So now it says Z is 3, Z equals 3, Y equals 2, X equals 5. That's what we came up with before, wasn't it? When we solved it by hand, by using manual operations. Right. When we did these operations, 1, 2, 3, 4, 5, 6 operations, and we ended up with 5, 2, and 3. Now, you want to know how to use these operations to manipulate the rows, but you also want to know how to use your calculator to solve these equations. Okay, you want to know both methods, because on your test you're gonna be asked to use both methods. Okay, questions on that at all, on how to use your calculator to solve this? Okay. All right. So let's try one more. Let's say we want to solve this. Where was the bigger one? This one? No, not that one. This one, the W here. Let's say we want to solve this matrix here. We didn't really solve it here. We solved a different one, but if we want to solve this one, we would set up a matrix that looked like the following. We would go to second and matrix and edit. And we'd say, well, you know, I don't want a 3x4. Let's say I want a 1, 2, 3, 4 by 5. 1, 2, 3, 4, 5. 5 columns, 4 rows. So I'm going to say I want a 4 by 5 matrix. So the calculator says, there's your 4 by 5 matrix. What do you want to do? And I'm going to say, well, I want to load up these coefficients here. So let's see, 1, -3, -2, 1, and -3. Did I get those in properly? 1, -3, -2, 1, -3. Good. Second row, 2, -7, -1, 2, and 1. 2, -7, -1, 2, and 1. That looks good. Third row, 3, -7, -3, +3, and -5. 3, -7, -3, 3, and 5. And the last row, 5, 1, 4, -2, and 18. So I've loaded my matrix, new matrix. Still called matrix A, this new calculation. It's a 4x5 matrix, and I've loaded it up. Okay, so I'll quit out of there, and I'll say I want to use the math operation in a matrix. And again, I want the reduced row echelon format. So I pull up the RREF function. That's a function. And in that function, I want to load matrix A, the 4x5 matrix. There it is. And if I press enter, the calculator very quickly comes back and says Z is -3, Y is 2, X is -1, W is 1. Okay, see how quickly that comes back? So we can then solve this matrix that we've seen here using our calculator. And we got W equals 1, X equals -1, Y equals +2, Z equals -3. And we got that very quickly using our calculator, entering the coefficients here. Questions?
In the test, are we allowed to use the calculator for these type of questions on all of the questions, or will we be specified?
You'll be told whether you can use your calculator or not, or it might simply say perform these row operations. You might be given a set of equations and it says use these row operations to generate a new augmented matrix. So just follow the question just answer the question that's asked. And if it doesn't say that you can't use your calculator, then feel free. If it says use your calculator, use it. If it says show me how you use these row operations, then you'll want to do that. So just read the question and make sure that you're doing what the question asks. Okay.
Okay, thank you.
All right, that's all I'm going to cover for 8.1 matrix solutions and linear systems. I'm going to stop at that point and go on to the last topic that we're going to cover. Get rid of all this extra paperwork around here. And the last topic is 8.2, which talks about inconsistent and dependent systems and their applications. And we're going to take a look at what that is, what that means. So if I have a set of equations that looks like the following. Now let's say x minus 2y minus z equals 5, and 2x minus 3y minus z equals 0, and 3x minus 4y minus z equals 1. So those are my three equations. And it might say something to the effect, solve this, and whether it says use an augmented array or no matter what it says, you want to make sure that you are answering the question in the way that it says to do it. So let's solve this one. Let me see how long this is. Let's solve this one in two ways. Let's solve this using an augmented matrix and row operations. And then let's solve it using the calculator. So we're going to solve it two ways. So first thing I want to do is create an augmented array. So that's 5, 0, and 1, 1, -2, -1. We should end up with something that looks like this, 1, -2, 1. Okay, so here's our augmented matrix. And now we want to do some operations and see what we do. So let's say I give you the operations that I want you to use. -2 row 1 plus row 2 We're going to replace 2. And then -3 row 1 plus row 3 to replace row 3. Let's see if we can agree on what we get here. Now we're not changing row 1 at all, so that's 1, -2, -1, 5. -2 row 1, that's -2, and add it to row 2. So we're going to get a 0 here, aren't we? Which is what we're looking for. 1, 0. -2 times 2 is +4, -3. That's going to give me a 1. -2, that's +2, minus 1. That's going to give me a +1. And -2 is -10, plus 0 is -10. So as a result of this operation, I get row 2. So here's row 1, row 2, row 3, and there's the column for X, for Y, for Z, and here's our constants out here. Okay, and then 3, row 1, that's -3, and add it to 3. So -3 plus 3, that's going to give me a 0 again, isn't it? And -3 here is -6. And let's see, -6, that's +6, negative. So this is going to be a 2, and this -3 row 1 plus row 3 is going to give me a 2, and -3, that's 15, plus 1 is 16, so that's going to be a 16. So it looks like I'll have negative row 1 plus that, -3 plus that. So it looks like I should be, here is going to take me to here. So here's my new augmented matrix. And I'm doing pretty well. I've got 1 followed by 0, 0. I still need to get that to be a 0, don't I? So if I do a row operation, if I say I want to get rid of this. So if I say -2 row 2, multiply this by 2 and add it to row 3 and replace row 3. That's going to work, isn't it? So I do -2, it's going to be -2 and add it to row 3. So this +2 becomes a 0. -2 here, add it to this. And what are we going to get here? Another 0. And -2 times row 2, that's +20. And plus 16. Let's see. 10, 0, 0. Looks like that's going to end up being a -4, isn't it? -10. I think that's going to be -4 when we do our multiply. So -2 row 2, that's 20. And 16, -20, +16 is -4. So we've done 3 row operations. We've generated what we wanted to generate, 1, 0, 0, 1, 0. And then we ended up with a 0 down here. Now remember what we wanted along this diagonal. We wanted 1, 1, 1. And we did our row operations to get 1, 1, and 0, 0. So we've got everything we wanted here, but we ended up with a 0 here. Now this tells us that 0x plus 0y plus 0z equals -4. That's what this is telling us. And we know that can never be true, can it? Never true. So this is a false. That's a false condition. And if that's a false condition, what this matrix operation is telling us by doing 1, 2, 3 operations is that there's no solution. So the solution set is the empty set, which looks like that. Okay, so what this says is there are going to be times when you use an elimination method and you won't have there's no solution. There turns out that we don't have a solution. Now let's try this with our calculator and see if it agrees, or let's see what the calculator says when we input it. So into our TI-84, let's just do second matrix and edit here. And we want a 1, 2, 3 by 4. It looks like matrix here. So we want this to be a 3 by 4. So the calculator says, okay, there's your 3 rows and there's your 4 columns. What do you want to put in there? And I'm going to say we want to put in 1, 0, 1, 0 for the first. Let's see. Yeah, let's put in. Well, let's just load. Let's just load the values. So X was 1, Y was -2, Z was -1, and our constant was 5. So row 1 is 1, -2, -1. 5, row 2 is 2, -3, -1, and 0. And row 3 is 3, -4, -1, and 1. So let's make sure here. So we get 1, 2, 3, -2, 3, 4, -1, 1, 1, and 5, 0, 1. Okay, so we've got that loaded. So we've loaded up and we'll go into our matrix operation and we'll do a math operation and we'll say that we want the reduced row instruction set format. And we'll say we want to load a matrix, the 3 by 4 matrix. And it looks like it sets us up with same thing. 1, 1, 0, 0, 0, 0, X. Let's see, get this over here where you can see it. So it sets it up with 0, 0, 0. So that says X, Y, Z for the columns. 0 Z's is 1. And we know that that's never true, is it? 0 is never equal to 1. So the calculator did the calculations for us, but we have to interpret them saying that because this can never be true, the solution set is the empty set, which is what we see here. Does that make sense to everybody? Questions on that at all? Okay. Let's see. How about this one? What if I give you, get a clean piece of paper here. What if I give you X plus 2Y plus 3Z equals 70, and X plus Y plus Z equals 60. And you're asked to solve this. And you say, well, let's see, if I put these two equations and I put those in my format here of an augmented matrix, that would be 1, 2, 3, and 70. And this is X, Y, Z. And this is 1, 1, 1 for these ones here. So these are all positive. And that's going to be 60. And we can say, well, we ought to be able to solve this fairly quickly. Let's see here. What row operations could I use? If I did a negative row 1 plus row 2, so negative row 1 would be negative 1 plus this. So here's row 1, here's row 2. So my row 1 doesn't change. That's still 1, 2, 3, and 70. But row 2 now becomes negative row 1, which is negative 1 plus 1. So row 2 becomes a 0. And the second term, what does the second term become? Negative 2 times negative 2. Or negative times negative 2 is negative 2 plus 1. That's going to be negative 1, isn't it? And negative times 3, negative 3. And what do I get over there? Negative 2. Negative 3 and 1 is negative 2. And negative this, negative 70 and 60 would be a negative 10, wouldn't it? So rather than rewrite everything, I'm just going to put them in here. So after doing this row operation, I got the 1 that I wanted in the upper left. I got the 0 that I wanted below it. But I got a negative here. So I need to change that. So I'm going to flip that by saying negative row 2. Okay, so I'm just going to multiply row 2 just by a negative 1. So this becomes a positive. That becomes a positive. And that becomes a positive. So we get 0, 1, 2, and 10. You get this down here. That's good. So now we can express, we had X, Y, and Z. So we could say this is Y, 1Y plus 2Z equals 10. So we can solve this for Y in terms of Z, and we can solve it for X in terms of Y. We could say X plus 2 times this thing, which is, if we solve for Y, we get 10 minus 2Z, don't we? 10 minus 2Z plus, we're substituting back into here, plus 3Z equals 70. And then we can solve X plus 20 minus 4Z plus 3Z equals 70, or X equals, simplifying, 4. So we end up with 1Z, and we take away the 20 from 70, I guess 50 minus, that's going to be plus a Z, isn't it? This is going to be minus on the left, bring it to the other side. So X in terms of Z is 50Z. So this is interesting in that we get Y plus 2Z is 10, or Y equals 10 minus 2Z. X equals 50 plus Z. And in this situation, you might say, well, we have the answer in terms of Z. And it could turn out to be that Z happens to be some function of time. So it might be Z varies with some function of time. So if you let Z equal time, and then we could say, well, then if the solution for X is 50 plus T, if Z, for instance, is time and X is dependent on time, then we could say 50 plus T, or maybe a better way to write that would be T plus 50 for the X value, negative 2T plus 10 for the Y value, and just T for the Z value. And that says that we have a problem where this looks like it could be a motion problem where X and Y are dependent on time, which would be called a parametric equation. So if we have X and Y and some point out here varies depending on the value of time. At t equals 0, X and Y is here. At t equals 1, it's at some location, t equals 2, and so forth. So this is all we're doing here is showing that we can solve a system of equations and end up with the X and Y as a function of t or of z, and we'd have to be told that z is some function of time. Kind of an interesting approach to solving real world problems using augmented matrix and matrix forms to solve the equations. Question on that at all, what we've covered there? And let me see if I've got any other interesting problems here for you before I, let's see here. I'm going to stop at that point and simply ask for questions. It's 4:47, 4:48, somewhere in there. We've got about 20 minutes left in class, and I've got other problems I could present, but I don't think there's any new concepts. So I'm going to stop at this point and ask for any questions on anything we've covered on anything today. No questions at all? Go right ahead.
The question we did before this one on the calculator.
Anytime we're using the calculator, we just enter the values. Let's see. We just enter the values as shown. Let's see, turn this thing on. So anytime we're using the calculator, second and matrix, and then we have to load the calculator with whatever values that we want to put in there. Now for this one, the calculator is going to end up showing the same thing. We're going to get same values we show here. I can take you through that if you want, but it's not going to interpret it for you. It's just going to say that your solutions is going to look like this, and you'll have to determine what that is. So I think it'll let me put that in there. Let's see. We want this to be a 2 by 4. Let's see if we put in a 2 by 4 matrix, 2 by 4. And let's just see what it gives us here. 1, 2, 3, and 70, and 1, 1, 1, and 60. So we've loaded that up. And we say, let's pick which one we want. Let's say that one. And we'll pick our matrix. And comes up and it says X, Y, Z, 50, and you notice down here we end up with the same thing. So Y plus 2Z equals 10. Okay, that's what we ended up with here. So it gives us the same result. Here's the same result. X is 0, Y plus 2Z equals 10, which is what we had down here. Okay, and then we back substitute to solve for X and Y, but we're only solving in terms of the third variable. And the idea here would be the third variable. If we don't know the third variable, then we can only solve it in terms of X and Y as a function of Z. But if Z is a function of time, or Z equals time, then we can come back and say, well, then at time t, the location of X is here and the location of Y is here. So when t equals 0, we could say, well, X is 50 and Y is 10. So X is 50 and 10. So at time t equals 0, we're at 50 and 10 at t equals 0. And you might, depending on what the function looks like, at t equals 1, we'd be at 51. So at t equals 1, X would be at 51 and Y would be at 10 minus 2 or 8. So X is at 51 and y is 8. So, so we're moving in this direction as a function of time. And we could plot that if we wanted to. If that were the question, what does this plot look like over time? But in a table of values for t goes from 0 to 10, calculate x and y as t goes from 0 to 10. We could plot what this curve looks like as a function of time, and our calculator could do that for us, as shown here. Other questions?
I have one that's not super related to the concept we learned today.
Go right ahead.
So will the final be on the 13th or the 15th?
Whatever I said, let's see here, 15th.
Okay, cool. So we'll have a little bit more time in between a review for the final and then the actual final than we usually do between classes.
Yes, the final will be on the 15th, which looks like that's a Monday. Let me check my calendar here. The 15th is a Wednesday. So this is Wednesday. So Wednesday, the 15th at regular class time, 3 to 4:50, which is what I have here. And I don't have anything formally assigned here for the review for final. I'm just going to take whatever questions you guys have for anything we've covered throughout the quarter. The final covers everything from chapter P, the prereq chapter, chapters 1, sections 1 through 10, chapter 2, sections 2:1 to 2:8, chapter 3, 3:1 to 3:5, section 7:1 and 2, 7:4, 7:5, and then 8:1 and 8:2. So the final can cover any of those sections that we've covered in class. Hour and 50 minutes, 3 o'clock on the 15th. Yeah, be sure you log on early. Log on at least by 2:50. Make sure that everybody's logged on. We've got everybody checked off, and then we'll send out the final exam. Other questions?
Wait, so on Monday, are we still able to, like next Monday, are we still able to go into your class and ask questions? Since like I don't see that you scheduled anything for next Monday.
Next Monday is the 6th. No, next Monday is the 15th. No classes on the 13th. There are no classes.
Oh, okay.
It's called Student Success Day. There are no classes on that day. Finals begin on the 14th, and we don't meet on Tuesday, so your final will be on the 15th, which is Wednesday.
Professor,
sense?
how many questions on the final?
I don't know, 20 to 30, I'm guessing. You had 10 on your previous, and this is double the time. So it'll be more questions, at least double, I imagine.
Okay, thank you.
Sure. Other questions?
How would you recommend we study for the final?
The best way to study for any of my tests is to review the examples in each of the sections that we covered. Use the same method that we use for studying for the regular tests. Make sure you go through all the sections, cover all the examples, make sure you cover all the homework problems that you've done. The tests are very much like the homework problems and the examples in the sections that we've covered. There shouldn't be any tricks or anything that would cause you a problem. And most everybody's done pretty well on the test. So I don't think I don't think you're going to have any issues on the final. Other questions? Okay, everybody, let's see. So we'll see you on the 8th. And I'm going to say that's optional. You can attend or not attend. I'm primarily going to just look at your questions and just kind of talk about whatever you want to talk about for that, however long time we're logged on, whether it's an hour or 2 hours, however we're logged on for. We'll talk about whatever you want, then we'll come back on the 15th at 3 for an hour and 50 minutes. That's how much you'll be allowed for the final. And I would recommend that you get here early. Sometimes we have people, I never understood it, but people arrive late to a final. You don't get any more time just because you arrive late. The final will stop at 4:50 sharp. no matter what time you sign in. So if you want full amount of time, you want to be logged in early, and I'll send out the test sharply at 3. And if you log in after 3, then you'll have to contact me, and then I'll find the final and send it out to you. And whatever's time is left, that's how much you'll get on the final, which will be less than an hour and 50 minutes. So please log in early. Other questions? If there are no other questions, have a good evening, and we'll see you on the 8th at 3 o'clock.
Thank you, Professor.
Thank you. Bye-bye.
You.
Thank you. Have a good day.